Lerato and Magwena, please share with us what the answer should be for number 2.
I got 1 over 2 root x times root 1 minus x.
Please repeat.
1 over 2 root x times root 1 minus x.
Question. You're missing something. Think about it quickly.
I don't know, like.
No, think about it. Like you're missing something very small. Everything is fine. You're missing just one small thing.
Let's find out whether maybe the partner can be able to help.
Okay, cool.
Partner?
Yeah. Yes, sir. I got -1
There we go.
over 2 root x minus x minus x squared.
You cancelled everything. You said You said no. Please start from the beginning, Magwena.
Okay. Okay, I'm starting over. I
Yes,
got
please.
-9 over 2 root of x open bracket 1 minus x.
Ooh, ish. Makwena,
Yes.
look at it
Again.
again. Look at it again. Look at it again. No, like look at your denominator again.
I got a different
what is your angle? What is your angle? Your angle is root of x, right?
Yes.
And then when you square it, it's gonna be x, isn't it?
When you I get your angle is root x, but the root of x is the same as x to the 1/2 power, right?
Yes.
Yeah.
And then when you square that, what is it gonna be?
Okay. Okay. No, it's fine. But okay, Ndumiso, what's your answer? Let's hear what he's gonna say.
I have here -1.
Yes.
All over 2 root
Yes.
x.
Yes.
Open bracket.
Yes.
Radical sign. And then underneath the radical sign, I have 1 minus x and then close bracket.
There we go. That's what I was looking for. Thanks.
Comment. So.
Yes,
And you check my things on the chat. I've sent my workings on the chat. Please check it.
Okay. I don't see the message. I'll just wait for it to come in.
Oh, I see, Makwena. I see your thing. It came in.
Okay. Okay. My comment is
okay. So you put everything under one root sign. Okay.
Yes.
Okay. Oh, then you distribute it inside. Okay.
I agree with Makwena.
Okay. Yeah, it's cool.
You see what I did?
It's actually more simplified than my one.
That's the one.
It's still loading on my side, so I can't see Makwena's working out.
Okay. No, Makwena, it's great. It's perfect. Thank you. Better than mine. I'm sorry.
Simplified further.
Yeah, she did. She really simplified further, so it's cool.
Because 2 steps above, it's where we are.
Yeah, it's where we all stopped. Clearly, she's got foresight.
Don't overthink things.
Yes. Yes. Yes.
Well, for cos, it's -1, and for sine, it's +1. The numerator.
Cos is negative. So I was looking for the negative from you, Lakato. Yeah.
That I see it now. That cos, not sine.
Yeah, because also, and I'm glad you said this because I noticed it with the picture that Ishmael shared with us yesterday.
Yes.
He didn't have negatives on 3 of his functions, so that's why. So all the co-functions are supposed to be negatives, and then the normal functions are positives. And as far as I know, I stand to be corrected. On his document, he hadn't put the negatives on there.
Makwena, we agree with you.
Yeah, we do. So much so, dude. It's wow. Talk about taking it the whole way. Thank you.
For 2 marks.
Hi, wena.
Ah,
Hey, this guy.
Okay, Ndumiso, did we hear what Ndumiso needed to say? Because I think he needed to say something. Ndumiso?
Yes, sir, yeah, the image just loaded. No, Makwena, yeah. You did the things, yeah.
Yeah, no.
I agree.
She more than did the things, dude. Sure.
You agree?
I agree. Nice answer, yes, sir.
Okay, thank you. Please update me when people join.
We'll do so.
Thanks. May we please work out number 3 and then how minutes for it, Kanye?
Son of the soil.
It will soon be son of the moon.
Yeah, son of the galaxies. Hey.
Kanye,
Yes, sir.
how many minutes for number 3?
3 minutes.
Thank you.
Number 3, right, sir?
Yes, please.
All right, no problem.
Then from here, after these exercises, we are moving on to derivatives of exponential and logarithmic functions.
Woohoo!
I will request Erika and Zbusiso to lead us in number 3.
I got negative x squared all over the square root of, open bracket, 1 over x squared, close bracket, minus 1.
Are you sure?
Like I said, I think I might made a mistake somewhere.
Okay.
What did you get?
Okay. I got negative x to the exponent of negative 2 all over the absolute value of 1 over x multiplied by the square root of 1 over x squared minus 1.
Okay.
Yes. So, okay. Sir,
Can you repeat your answer, please?
my answer.
Especially the denominator.
Okay. I have negative x to the exponent of negative 2 all over the absolute value of 1 over x multiplied by the square root of 1 over x squared minus 1.
I agree with you.
Okay.
Me too.
I agree with you.
Can you please explain, Lucifer?
Okay. Do you remember the inverse of secant is 1 all over the absolute value of the angle inside the secant multiplied by the square root of x squared minus 1. Do you remember that?
From
Yes.
the note you studied, Ismail's note.
Yeah, Ishmael's. Okay, never mind. So what we have, let's say this. The inverse of secant is 1 over the absolute value of the angle inside secant multiplied by the square root of the angle squared minus 1. Then all that multiplied by the derivative of the angle. Are you following?
Mm-hmm.
Yes.
Yes, I'm
Then
following.
just take the angle and substitute it where I said the angle. For example, in the denominator, we have the absolute value of the angle, and the angle is 1 over x. So you just say absolute value of 1 over x multiplied by the square root of the angle squared. So you're gonna say bracket 1 over x close bracket to the squared minus 1.
Mm-hmm. And
Then
then
close all that inside the bracket, then multiplied by the derivative of the angle, which is negative x to the exponent of -2. If you take if you change 1 over x to a normal variable instead of a fraction, you get x to the exponent of -1. When you derive it, you drop down 1 and you minus 1 to the exponent, which you get -2. And when you multiply that, you have the same answer.
Nice, man. Thank you. I like it.
Before I can listen to the others, I'm interested in understanding whether the two agree, Erica and Species.
Yes, sir. I
Erica.
agree with him. I found my mistake. I forgot about the 1. Somewhere I lost the 1. But I
Okay.
found it now, yes.
Species one?
So it seems we are in the same page. So as long as Erica is sure that she understands what I just explained, then we are good.
Thank you for
Yes, I'm
helping
sure.
Erica find the missing one.
No problems.
Yes. Family, do you agree with the answer that Species and Erica have provided?
Yeah.
Yes.
Yes.
Okay.
Too
Thank you.
happy.
Lerato, do you agree?
Yes, I agree. I'm on
Okay. Thank you. Now let's see. Okay. What we can do next. Please, who should I ask here? Lavidelia. Lavidelia,
Yes, sir.
do you see number 4 and number 5?
Yes.
How many? I would like us to do both at once. Is it okay? Or should we do one and then do the other one later? Advise me. Please.
Do
Both
them
is fine.
one at one.
Sorry?
You can do them
Both.
both.
Both at once.
Yes.
Yes.
Okay, then how many minutes then for both?
Ash, I'm not sure. You can ask someone else.
Nope. Decide for us, please.
4.
4 for both or 4 for each?
4 for both.
Thank you.
Okay, thank you. You have got 4 minutes. Tani and Ishmael, I'll request you to lead us.
Okay. Kanye, do you want to do the first one? I'll do the second one, or?
Okay, I'm gonna say my answer for the first one. I'm not sure if it's
Okay.
correct, but I got -1 over 2 absolute value of x, the square root of x squared minus 1, and then times cosecant, the inverse of cosecant x. So that was the first one I got. I'm not sure if it's correct.
That's what I got as well.
Okay. What did you get for number 5?
So for number,
Please. Let's talk to them about number 4 before we go to number 5, please.
okay.
I'm sorry for speaking to you like that.
Can
You
you
got
Yes.
like number 4? Is your
Yeah.
answer? If it's from this step, because I cannot simplify that, that's why I'm asking. Is it like half times cos times square root of inverse of cosecant, and then times that bracket, huge bracket,
Times which bracket?
like -1 over absolute value of x square root x squared minus 1. At the
Yeah.
end.
Yeah, and also for the inverse of cosecant x, it is to the power of negative half.
Negative half.
Yeah, that's
I
what I
agree.
thought. Okay. Did anyone else get a different answer, perhaps?
Please repeat your answer again.
Okay, so I got a half times the inverse of cosecant x to the power of negative a half times -1 over the absolute value of x times the square root of x squared minus 1.
Okay. Kanye,
Yeah.
sorry to be a bother. Do you mind saying it just one more time, please?
Okay.
I'm so sorry.
1 over 2
-1 over 2, ne?
positive 1 over 2
Okay.
times
Yes.
the inverse of the cosecant x
Okay.
to the power of -1 over 2
Oh, okay. 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 Mm-hmm.
times
Mm-hmm.
-1
Mm-hmm.
over
Mm-hmm.
the absolute value of
Mhm.
x
Mm-hmm.
times the square root of x squared minus 1.
Kanye, it's beautiful, man. Thank you.
Does
ask a question?
everybody agree with Ismail and Kanye for number 4's answer?
Yeah, I do.
Yeah.
Yes, I agree, but can't you simplify it more?
Yes, you can, Erica. I did.
Okay. Okay, just wanted to make sure.
Yeah,
Thank
so what I
you.
ended up doing is, oh, sorry for disturbing. You were speaking. Sorry about that.
Now you can continue.
Okay, I was saying, you know how Kanye gave us the, she gave us the inverse of cosecant x to the power of -1/2. I turned that back into a square root and I moved it to the bottom.
Yes, that's what I've got as
And
well.
then at the top, the only thing I kept at the top was the -1, and then everything else was at the bottom, and it was turned back into positive square roots. But other than that, same thing.
Okay, thank you very much. Yeah.
Cool. Thanks, Erica.
Thank you, Kanye. Thank you, Ismail. Please continue with number 5.
May I please ask a question?
Yeah.
Yes, Dumiso?
In the denominator, instead of the absolute value of x, I just have x there. I'm not sure if
Dumiso,
And the absolute value of x
sorry,
are not the same thing.
Sorry?
Kanye and Ismail, and anybody can come.
I was saying x and the absolute value of x are not the same thing.
Okay.
Yes.
Yes.
Okay, thank you.
Thank you, brother. Ismail and Kanye, number 5.
Okay, so for number 5, I got 3 open brackets, 1 plus tan inverse x, close brackets squared, all over 1 plus x squared.
I agree.
I agree also.
I agree.
So,
Agreed.
Positive
Kanye,
2.
Sorry?
Positive 2 to the power of 2.
That's what I
Yes.
said, yeah. Yeah,
Yes.
positive, yeah.
I agree.
Kanye, do you agree with what Ismail said?
Yes, sir, I do agree. Does anyone else have a different answer, perhaps?
Can you repeat the answer, please?
Okay, so 3 open bracket, 1 plus inverse of tan x, close bracket, all to the power of positive 2, and then all of that divided by 1 plus x squared.
Agreed.
Thank you again, Ismail and Kanye, for leading us. Thank you, members, for participating. In the next exercise, Theo, I
Yes.
think, let me check my permutation here.
All right.
Oh, no, this one is of yesterday. Now, next it will be Theo and Indomiso.
Yes.
Okay, are we all happy up to so far?
Yes, sir. I'm happy.
Okay.
yes, sir.
Now let's see. Number 6 and number 7. Now, where should I go? I don't know. Let me ask Ishmael. Ishmael,
Wow. Okay.
Ishmael. Lerato will say 30 seconds for each. Ishmael.
Let's
Ishmael.
go with, yeah. Can you hear me?
Yes, I can hear you. How
Okay.
many minutes for both? 6 and 7. How many
Yeah,
minutes?
let's go with 4 minutes again for both.
4 minutes. Okay.
Mr.
Thank
Mr.
you.
Ishmael, please add a small buffer there, please.
Okay, 6 minutes.
Thank you.
Okay, thank you. Theo and Ndumiso, please lead us in both, starting by verifying number 6 before going to number 7. Thank you.
Okay, sure, Theo.
Sure, man.
So for number 6, I have 2 open bracket, the inverse of cos 2x close bracket,
Okay.
all over
Mm-hmm.
radical sign,
Yes.
and underneath the radical sign I have 1 minus 4x squared.
Please repeat that again from the beginning. I'm so sorry.
Okay, in the numerator I have 2
Okay.
open bracket, the inverse of cos 2x close bracket,
Okay. Yes.
and then in the denominator I have 1 minus 4x squared, all square rooted,
Okay.
plus
Okay.
2,
Mm-hmm.
the inverse of sine 2x,
Okay.
all over 1
Mhm.
minus 4x squared, all square rooted.
Okay. Can I ask you something?
Yeah.
For the second part, do you have 2 or -2?
I have -2. Sorry. It's negative. Negative.
I agree with you.
Okay, now, if there is an agreement, please, members, please pay attention. Then Theo and Ndumiso, please share your answer that you are agreeing on again.
Okay. Oh, you want us to repeat the answer?
Please.
Okay. I'll take the reins. It's basically the same thing. So it is 2 multiplied by inverse cosine 2x, and then all of that is over the square root of 1 minus 4x squared, or x squared squared, if you must. And then it's plus -2, or it's -2 times the inverse sine of 2x, all of that over the square root of 1 minus 4x squared, or the square root of 1 minus 2x squared, whichever one floats your boat.
Members,
Agreed.
any disagreement?
I'm not sure I have 2 answers.
Okay.
Yes, Lerato.
The denominator, mine, it's 1 minus 2x, and then the other one is 1 minus 2x squared. Square root of 1 minus 2x squared. The other one is just 1 minus 2x. That's why I'm asking.
Okay.
Because like does that squared cancel out the square root?
No, so remember the squared only applies to what it's next to at that point in time. Doesn't apply to the whole thing.
Oh, that's not for tan only, whereby it applies to x only.
Because I see what you mean, where the thing is, Angiti, you saw 1 minus, let's say, for example, I'll give a strange example. Let's say under the square root, we've got 1 minus x squared. You would have then said the square root cancelled out the square for the x squared, right?
Wait.
Okay. Because I actually know what you're saying, but let's try get on the same page with each other to make sure I'm not confusing myself.
I'm confused between the denominator. square root of 1 minus 2x squared, or square root of, in bracket, 1 minus 2x close bracket squared.
The second one.
Then why doesn't it cancel? Because the second one.
You know
That
why?
means-
It doesn't, you know why it doesn't cancel. So the reason why it doesn't cancel is, look at it this way. For it to cancel, you would have to separate. It always cancels if it was under the square root. You had 1 times, let's say 1 times whatever the next figure is squared, because that's the same as 2 radicals next to each other. Then the 1 would remain as it is, and for the second radical, the square would cancel out the square root. But in this sense, the 1 minus 2x squared is one entity. I hope that makes sense.
So the squared, it's for one
Yes.
thing. It's not for everything.
Yes, it's not for everything. Whereas if it was for everything, then the square root would cancel out the square. So it was going to work like that. Or if you had a situation where under the square root you had a multiplication, because if you have a multiplication under the square root, you can separate those entities into 2 separate square roots, and then the one that is squared will then cancel out with its square root, and then the other one will remain as it is. But if it's a plus or a minus, it's all one entity.
Yeah, I agree. My
Okay.
second agrees.
Okay, cool.
Okay, thank you, Theo and Dumiso. That was number 6. Please proceed to number 7.
Dumiso, do you mind taking the floor?
Yeah, I was about to say, can I go first? Because I struggled a bit with this one.
Okay, cool. I got -1 over x squared plus 1, and that's multiplied by inverse tangent x squared.
Yeah, I got the same.
Cool.
Yes.
Can you repeat your answer?
Okay, it's -1 over, and then in the so we've got, in the first bracket we've got x squared plus 1, and that is multiplied by inverse tangent x squared.
I've got something different.
Me too.
Okay.
Can you guys please share with us?
Wait, the first question, where did you get the negative?
The first question, the negative is there.
You're making it
Is there?
like, I agree with the negative. This is chain rules, Busiso. It's not quotient rule. So it's inverse of 10x to the power -1. -1 comes to the front. And then you do the, you know, man, what you do in chain rule. You know.
Oh, Lagan.
So, Theo, well, guys, I'm just, so when you differentiate the inverse 10x, so basically I've got it as y equals to, open bracket, inverse 10x, close bracket, all to the power of -1/2. Now, if you differentiate the outer bracket first, don't you end up with -3/2? So
Can I ask you for, would you be able to post your solution online?
okay.
I mean, on the group chat. Sorry, it was on the online ones.
Okay, while the solution is being posted, people explain to me. We have 1/tan inverse of x. So you're telling me you took the inverse of -1 and put it outside on a bigger bracket and left tan x inside?
No.
Then did the chain rule.
Oh, it's tan inverse of tan x to the power -1, and then you do chain rule.
Yeah, that's what I did.
Yes, that's what I also did. So what you guys are basically saying, just so I don't confuse my explaining, the one at the top was moved out and treated as a constant.
Yes.
Right, and then the 10 at the bottom was taken to the top and then the inverse tan ends up being an inverse tan to the power of -1. Then you use chain rule to get that, and then the rest is history, basically. And then you move it back to the bottom in the end.
Yeah, that's what I
Okay,
also
when
did.
you move tan, the inverse of tan to the top, you have minus. Then it
No,
becomes
yes,
tan,
but
not
think about it. The inverse
minus
is
tan.
inverse. We're just moving.
It's like
an
saying
electron-
1 over negative.
Okay. Okay.
Okay,
No, it's fine.
Here's
fine.
a question. Here's a question. Here's a
Pussy
question
pro-
to you. Here's a
Mhm.
question to you. If you have 1 over x to the exponent of -1, what's that?
You know what? Give me 2 seconds, okay? Give me 2 seconds. I'm
So-
gonna try to rewrite my whole thing longer, and I'll post it because I understand your frustration. Trust me.
Yeah, answer the question to you. If you have 1 over x to the exponent of -1, what is that?
So
Can I
Answer the
answer that?
question.
Say answer it yesterday.
yeah.
Oh, so
Can I answer?
Yeah.
So your question is, if you have x to the power of -1, if you differentiate it, it's gonna be 1 over x squared, isn't it?
Listen to the question. If you have 1 all over x to the exponent of -1, what is that?
It's okay.
That is x.
It's okay. I'll just repost this whole thing. It's fine.
This is how
Nobody's
I did it.
answering the question, man.
No.
Answering the question.
Okay.
It becomes 1 times 1 over x.
Okay, Lagad. If you have 1 over x, what do you have? When you change that, if you have 1 over x, what do you have?
it's going
the
x
power-
raised to the -1.
So what you mean is we have tan of x in this case. We don't have an inverse of tan. If that's
That's
how
what
you're
he's
putting it, it means we have y is equals to tan of x.
Okay. I'm almost done. 2 seconds. Over.
There's a p.
Yeah, I'll also post my solution, and I hope it's gonna make sense to him, because I didn't want to explain it and fumble it. So I think this is gonna be best.
Ismail.
Did Ishmael post the picture?
Like Ismail
Yes, I did,
answered
but I'm not.
the inverse of 1 over square root of tan inverse. That's what he answered.
Ishmael,
Yeah.
where did you get the
Half.
negative half? Yes.
Okay.
Well, so I didn't think you could move. I didn't think you could move 10 minus 1 to the top, because then you've got 10. So I thought 10 inverse 10x would be, oh shit, but hang on. Sorry, you're right. Yeah, that should have been -1, not -1/2.
Guys,
Yeah.
can I post my solution and try explain it to the guys?
Yeah, I got that completely wrong.
Please do.
I'll post it, and hopefully it will explain everything, because I feel like when I'm looking at it, I can better explain it to whoever has a question about it. Because again, I understood the question, I just was struggling to explain what I was doing. But yeah, here goes. Give me like a few seconds.
Busisa is shocking me now.
Aim for. No, but you know, but at the same time, I'm glad, because Angiti, this is why we're together, so that we can question each other and question the stuff we do. So I'm happy with it, dude. Let me see. I'm using this thing today. I must post from here. Come on, V. Oh, there. Okay, cool. All right. Okay, it's coming through. Give me a few seconds. Tell me when you. I'll start explaining.
Dennis has joined, and Theo's thing I can see.
Okay. Please let me know if I can start.
Thank you, Lerado.
Hi guys, sorry I'm late. I just got home.
It's okay. Welcome, Dennis.
No problem. Welcome.
Konji, who wanted me to explain? It was Busiso, ne? Hello?
Please talk to
Hello.
Theo.
Hello?
Yes,
Who's
it
this
has
the one that you to
skipped
explain,
town.
right?
He skipped
So
town.
Hi,
So
boy.
it's here. And Theo, can I say something, Theo?
Yes, yes.
Okay. Theo, let's say this. 1
Can I
over tan.
explain?
Let's not take the inverse. 1
Wait,
over
can I
tan.
explain? Look, can I explain first?
Okay.
Please hear me out. And I can tell we're all getting very frustrated, but I just beg for 2 minutes of your time, please.
I'm listening to you. I'm listening.
Thank you. So we're supposed to find the derivative, the derivative of 1 over inverse tan x. So yes, the one thing I always thought about it was, if you look at inverse tan x, it by itself as a whole is raised to the power of 1, right? Forget the fact that, because the thing is, remember that the -1 to the tan just tells you it's an inverse, but the whole entity as itself, inverse tan x itself, is raised to the power of 1. So to differentiate that, what we know in calculus, in order to differentiate something that's in the denominator, you always want to move it to the top, differentiate it, then bring it back to the bottom. So what I did is I was like, yes, what do I have here? It's not a quotient rule situation, number one, because it's not a function over a function. The one at the top is a constant. So I move the 1 out, and I'm going to multiply it in later. I was like, okay, sharp. Move the 1 out, and then I'm left with inverse tangent of x. Then I move that to the top. So inverse tangent of x is now what used to be inverse tangent of x to the power of 1 becomes inverse tangent of x to the power of -1. And then I apply, what's the rule called again? What's it called? That rule where you drop, yeah, but anyway, so I drop the -1 to the front and then a -1. So again, derivative of the outside, leaving the inside the same, times derivative of the inside. When the -1 is dropped, I get 1 times -1, and then my power for inverse tangent of x goes from being -1 to being -2. That sorts that out. And then it's multiplied by the derivative of the, yes, derivative of the inside we all know how to do, because now you're calculating the derivative of inverse tangent x, and that is 1 over x squared. Agreed? And then to sum it all together, what we have then to put everything together is 1 times -1 is -1. And then we still have the inverse tangent of x to the -2 multiplied by 1 over x squared. And then to make things easy, because you don't want to have negative powers, the inverse tangent of x to the -2 moves all the way back to the bottom again, and then it becomes inverse tangent of x, the whole entity squared, multiply by 1 plus x squared. I feel like it's as simple as it looks. I hope
Okay.
it
I
makes
done
sense.
Theo. I done.
Yes.
Okay. Follow me then. Follow me.
Yes.
Okay. If you have tan, just tan of x.
Yes.
If we say 1 over tan x,
Yes.
what is that?
No, that's a reciprocal.
Yeah, which is
Isn't that cotangent?
exactly.
Can I help?
Can I
But here's the thing.
can I get
Busiso, we're not looking for reciprocals, we're looking for derivatives. Cotangent can be
Yes, but
1 over tan x.
you can cotangent can be written as 1 over tan x.
Yes,
Meaning
but
1 over tan x can be written as cotangent x.
okay.
Or no?
In that case, let's do
Busiso.
this. He's doing
Yes,
the
Mabwe,
Lerato thing. He's
Mabwe,
overthinking.
Okay,
I'm
okay,
not
Sbusiso
overthinking
and
it.
Theo. Okay, hang on. Please hang on. Sbusiso and Theo. Mabwena, you will follow, followed by Lerato. Then Sbusiso and Theo, please go ahead.
Okay, yes, so please continue.
Okay, follow me.
Mm.
If you have 1 over tan, we are saying is the same as cotangent, right?
Yes.
So we can change 1 over the inverse of tan x to cotangent, to the inverse of cotangent x.
Okay.
Then what's the derivative of cotangent x?
The derivative of cotangent x is negative cosecant x squared.
No. It's -1 all over 1 plus.
No, you said
X
to me the
squared.
derivative of cotangent x. Didn't you ask me that?
The inverse, Theo. You're talking about the inverse, man. I'm sorry. The
Oh,
inverse.
I kind of see what Spusis was saying.
yeah, we do. But again, okay, what answer did you get then?
It's -1 over 1 plus x squared.
Okay. Okay. Family members, what did the rest of you get?
I got the same thing as yours, Theo. I have a question for Usbusiso.
Okay.
Usbusiso,
Yes.
is 1 over tan x the same as tan inverse of x? Is it the same thing?
No, it's not.
Are they the same?
No.
No.
I want to.
No.
No, it's not. And that's the thing.
Can I-
And I'm glad
No,
you
can you listen to me, T? Can you take a piece of paper and write down something, T?
I don't need to write it down. It's
Okay.
fine.
No. You're misconfusing my words, people.
Yeah,
Sibusiso, I think you're getting confused with that -1 thing. The way I look at it is anything like any of the trig functions with to the power of -1 is just another function completely. It's got nothing to do with the like, because you and I think you see.
Okay, here's my question, people.
Ishmael, can I say something?
Yeah.
I'm glad you're saying that, because there's a difference between tan to the -1x and tan x to the -1.
Yeah, that's what I'm trying. So I think a lot of guys are getting confused with the power -1 by the 10. So they should have maybe just given it another name.
Yes, because tan to the -1x is inverse tangent of x, and then tan to the x of -1 is the reciprocal of tan. But yes, anyway,
Theo,
yeah. Yes.
Theo. Here's the question.
Wow.
Can you write tan inverse of x as sine inverse of x all over cos inverse of x?
I don't know. You know what? It's look.
How do you get tan?
You know what? Look, I'm gonna say what I said yesterday. I didn't overthink the thing. I looked at it. I was like, "What's the simplest way to solve it?" And I did it that way.
There's no
That's
overthinking here, people.
No, I'm talking about myself. I didn't say you're overthinking it. I said I didn't want to overthink it, and I said I solved it based on what to me looked like.
Okay, here's another question, Theo. Then let's not complicate things. Here's another simple question.
Oh,
simple.
boy.
Follow me step by step. Follow me step by step, and then on a piece of paper, please write 1 over. It's an example. Tan squared x for me. And then
Okay.
the reciprocal of that is the same as cot squared of x. Am I lying?
You said 1 over 10. You said 1 over 10.
Yes, 1 over 10 x squared x.
1 over 10x is cotangent of x. Yes, I know this. Because I think 1 over 10x is basically we're talking about reciprocals, and then the reciprocal of that is then cotangent x.
Okay. So if you have 1 over tan inverse of x, why can't we have cotangent inverse of x? Inverse of cotangent x, I mean.
I don't know, man. I don't know. Look, all I can say is I'm just gonna wait for Sir to give us the answer.
Okay.
So in essence, you're saying that 1 over 10 inverse of x is the same as cot inverse of
cotangent x. Yes.
Okay. Yeah, I don't know. I guess we'll have to see the answer and just verify.
Let's just wait for the answer, and then when we have the answer, we can pick it up again. Because then once we know which one of us is right, then we can see where the other one went wrong.
Sir,
Hello?
yesterday we did question 5.
Yes.
I'm not sure if it's yesterday, it's when. It was 1 over sine. 1 over sine squared. But then
Lerato. Can I ask for your permission to please interject and ask a question that's not related to what you just said? Please.
Ask.
Thank you. Spusiso.
Yes.
Can I ask you something?
Yes,
so
yes,
you know how on number 7 is y is equals to 1 over inverse of tangent x, right? And we are basically arguing over how to treat it. how would you have treated it if the question was actually 1 over inverse of tangent x cubed?
Mhm.
How
1
would you have
over
done it there? Yeah, if it was 1 over inverse of tangent
1
and that was
over
all in brackets cubed, how were you going to treat it then?
Take it to the
1
top.
over tan
Thank you.
inverse.
Yeah, so let's say if the question was y is equals to 1 over, and then in brackets we have inverse tangent x, and then close brackets, and then all of that thing and in the denominator to the power of 3. How are you going to get that derivative there?
To the top.
Thank
Okay,
you.
I was gonna say,
Mm.
because you have an outside exponent, which is your cubed, you can take that cube to the top. Then
Okay.
you have tan inverse
Okay. Okay. And then
bracket -3.
perfect. Okay. From
Tan
there, we
inverse
know.
inside.
Yeah, we all know what you're going to do there, right? So if you agree that if they had given it to us that way and then they'd put the inverse tangent of x in brackets and cubed it. So are we then saying that if the inverse of tangent of x at the bottom as it is, so you're saying it's not to the power of 1 as it is right now?
I'm saying that's the question I asked before, people. Guti, did you take the -1, the inverse of tan, and put it outside the brackets, the big brackets,
No, we
then took it
didn't.
to the top?
Remember, you see, and again, I think it's what Ishmael said, where he's like that minus
If
1
you
is.
didn't do that, how did you get the -1?
So look at it this way.
Because you use the power rule.
Yes. Yes. Because
Okay.
you see what what
I see it.
Can I
I
assist?
see your point.
do you see it? Because
Yeah,
I mean,
I see your
we know
point.
that, for example, if we have 1x, we know 1x is the same as 1x to the 1. The 1 is never there, but we always know it's implied. I need.
Yeah, I see it. I see.
Wow. Finally.
You win the case. But
No,
I still don't agree,
no, I
but
didn't
you
win
win
the
the
case.
case.
Nope, I didn't win the case. Nobody wins for as long as we disagree. None of us have won the case because we
Okay.
need to get to a point where we both agree on a way to do it. So none of us have won. Nobody has
Okay.
won.
Lagato, I wanted to say something.
Me, when I was in high school, and there's something they did which was
Yeah.
fun. And I appreciate it. Like, make u equal to tan inverse of x, and you'll get the same answer still.
Oh, if you did use substitution, yeah, actually.
You'll get the same answer. This one that you are getting here.
I see what you mean. So
Okay.
it's use
Can I
substitution, but
call Sir, please? Sir. This conversation won't end.
Oh, okay. Let's
Yeah, this
continue.
conversation.
If it is not going to end, then let's just may we please terminate it here and then continue. Or is there an agreement on an answer or no?
there is no agreement.
Sir.
Oh,
Democracy.
democracy.
Yes. Well,
Yes.
we have the majority is split. Yes, I guess, where other people feel.
They were
Oh,
convinced by Sbusiso that
okay.
This was wrong.
they were
Is
on.
that Magwena?
Hey,
Is that a yeah coming from Magwena?
Yes.
Yes.
Oh, thank you, my sister. So then, Ndomiso and Rio,
Yes, sir.
is this what you got?
It's what I got.
Yes,
Ndomiso,
I got that as
is this
well.
what you got?
Yes, it's what the
Thank
reason
you.
I got. Yes.
Oh, okay.
Sir,
Thank you.
before we continue,
Yes.
say something quickly.
Yes.
I guess then that this means that inverse tangent of x is indeed inverse tangent of x all to the power of 1, correct?
yes.
Please come back again. Inverse.
I guess
The
it means
inverse
that
of the
it means inverse tangent of x as given to us for number 7 is the equivalent of inverse tangent of x all to the power of 1.
all to the power of 1.
Yes.
That is an inverse of 10.
Yes. So basically that whole entity if it's bracketed, it's all to the power of 1.
Whoa,
One or negative.
No.
Hang
Look
on,
at
Negative
one.
one thing.
No, when it's in the bottom, it's 1. Angit, for number 7. Yes, that's what I'm saying. When you look at the original sum, it means when they gave us 10 to the negative 1x, if we were to put brackets around the whole thing, that means it's 10 to the negative 1x all to the power of 1.
I agree with that one.
Thank you.
That one I agree with.
Thank you, sir.
Thank you. Is everybody clear?
Yes, sir.
Okay.
Crystal.
All right. I ran out of options here. Oh, no. Don't worry. There is Dennis. Dennis. Dennis,
Yes, sir.
how are you?
I am great, thanks. How are you doing?
Cool. Hey, you know, we have been struggling. We don't know what we are doing. We have been struggling. Thank you for joining. We've been suffering. Now, let me say our suffering is over. So, I'm going to request you, okay, I have Dennis. I'm requesting anyone to join Dennis. Who will join Dennis?
Hey, I'll pass. Not today, not me. Sorry.
Who will join Dennis?
The soil is tired.
Spusiso will join Dennis.
Okay, thank you, Spusiso. Thank you very much, my brother. It's because I ran out of permutations here. Now, now we are going to Kanye. Kanye.
Look, they won't get the truth because I'm trying to redirect the question.
Okay.
Yes. So say if I have negative a, sir.
Negative a.
Yes, sir. And I say the absolute value of negative a. Is it the absolute value of a or just a, sir?
Can I try to answer?
Please help Theo.
So, I see it's what you told. So you said. So look at it this way. Is your negative, if we have brackets, is your negative outside or inside the bracket? It's always the absolute value of what's in the bracket.
Okay, D, listen to me. You have inside the absolute value, you have negative a.
Yes.
I want to be sure.
So
I've solved it, but
basically what you're saying is absolute value of negative x, right?
I need some.
So it's ln negative x. Ln negative x.
Hey, why did you go there?
Thank you.
We all know what you're asking, Angit. Just get to the point.
Not everyone knows.
You
Not
do that.
everyone
You
knows.
write 2 answers like me.
Yeah, because the thing is, what I would say is, I would literally be like, I'm looking for the absolute. I put a number there. I'm looking for the absolute value of -1, and -1 is wholly in the bracket. It's 1. But if it was negative,
So the absolute value
of 1.
of negative a is a.
Yes.
Okay.
But Spusiso,
Thank you. Yes, sir.
Isn't it true to say any number within the absolute value sign is positive?
Yes.
Yes, sir, I want to be sure, sir, because okay, sir, let me take you through how I proved it is a. So I was just wanted clarification, yes, sir. For the absolute value, say if you have a inside the absolute value, right, sir? A for any value of a that is greater or equals to 0, a will be positive, and for any value that of a being less than 0 will be negative. These conditions change whatever value of a to be always positive, sir. So I figured out if you have negative a and the condition goes to whatever value of a that is less than 0, we have another negative. It means you'll get a positive because those negatives will cancel out. But my problem was if negative a were to substitute it for the value of. Okay, sir, I get it. Sir. I get it.
Okay.
Oh, I'm also done.
Thank you, Theo.
Sure.
Lerato, Sibusiso, Erika, Theo. Yes, Lerato.
I wanted to ask something which is like, it's gonna sound funny, but then like,
Yes, Kanye. Thank you, Kanye. Okay, Lerato.
it's
The miss was
like
also done.
Thank you, Ndumiso.
since from Sibusiso's last question, I'm getting different things. The last question where they argued for like the whole day. You see, when you do like inverse of
Inverse of?
second,
Mm-hmm.
when you derive it, you get one answer, ne? And then you get another different answer. So I was wondering, those conditions like cot is equal to 1 over 10, when you derive, they no longer like derivative of 10x, it's not equal to derivative of sine x over sine x over cos x. That's what I'm asking.
Hey, please come back with your question again.
Like those things like sine over cos equals 10x, cot equals
Sine, okay. Sine,
over cos equals tan x.
yes, I got
When
that.
when you derive, they give you different answers. So I'm asking, does that mean when you derive, those things no longer apply? Like for 1 over sine is equal to second, and then 1 over cosine is equal to cosecond. They no longer apply when you derive.
When you say the word, when you use the word derive, do you mean when you differentiate?
Yes.
My brother, we are being guided here. If they just say to you, and I don't think, okay, let's say you are given sine over cos, and then you are required to find the derivative. What is it that you are going to have? You are having sine, you are having cos below.
Yeah.
Theo always has got, Theo explained this more than I don't know how many times, if you have got that. And then if you have got cot, we know what we need to use.
Yes. Okay, it's fine. We'll see with
But
questions.
you get me?
Yes, and
If you are finding the derivative of sine over cos,
yes.
that is different from finding the derivative of cot. Do we
Oh,
agree on that one?
yes, you agree on that one.
Okay. Have I answered you?
Yes, you
Lerato?
have. You have answered
Okay.
me.
Okay. Let's see. Magwen, are you finished? Ishmael and Dennis, are you finished?
I'm done.
Yes,
Yes,
I'm
yes,
finished
yes.
as well.
Magwen, are you finished?
Yes, I'm done.
Thank you. And Ishmael, Dennis?
Yes, yes, done.
Yes, we're done, yeah.
Okay, Dennis, then Ishmael. And now we agreed that Dennis and Sbusiso will lead us, ne? In both of them. So Dennis and
Yes.
Sbusiso, please talk to each other before you can tell us what your final answer is for number 8 before we go to number 9.
Okay, so Mr. Dennis, what's your answer? Mr. Dennis?
Dennis?
Skip town.
Skip town.
Oh, sure. Whoa.
Mr. Dennis is gone.
Skip
Is he gone?
town.
Oh, I thought he was done commuting from work.
Town.
Okay. If Dennis left, Sbusiso, please choose a
Please.
partner.
Is
Sorry?
mine?
It's Tando.
Tando.
Oh,
Yes.
welcome, Tando. Welcome, Tando.
Makwena, how are you? Thank you, sir.
Okay, thank you.
I was hiding, Makwena.
Tando, we don't have to hide, please.
No, sir, I'm very sorry. I had 2 other meetings, so they were clashing. It just ended now at 6:30. I'm
We understand, my
very
sister.
sorry.
We understand. Sbusiso?
Yes,
Sbusiso,
sir. Yes, I'm
would
here.
you please choose a partner?
Erica,
Since Dennis,
sir.
oh, you're choosing Erica. Erica?
Yes.
Erica?
Yes.
Would
Yes,
you
I'm here.
please partner with Sbusiso for both 8 and 9?
Okay, can I give you my answers? Because I also have to go to another appointment also.
Okay.
I'm listening you.
Okay, my answer for number 8, I got -1 over x and the square root of -x in brackets squared minus 1, all in the square root.
I agree. Sbusiso, I'm not sure if he heard.
Erica, please say it again. Sorry again. Sorry about that. Please say it again.
Okay, I've got -1
Mm-hmm.
over x. Okay,
Mhm.
the denominator is x
Mm-hmm.
with the square root of x squared minus 1.
I agree with you.
I also agree.
I
That's
agree.
for number 8.
Then we seem
now
to
I
What is
agree.
the
Yes.
I got a different
Uh,
answer.
What about the absolute value?
Answer.
Who's talking now?
My
Okay,
absolute
Lumis.
value I took as it's a negative because in the brackets is negative.
Yeah, so
So the
what you-
absolute value is negative. That's why there's no absolute value.
so negative x
Okay.
basically becomes x.
May I please come in?
Please do.
Erica,
Yes, sir.
is there an agreement between you and Sbusiso before we can come in?
Did you see so?
Yes, we agree. We are absolutely most definitely agree, sir.
Okay. What is the answer?
It's
Everybody, please pay
-1
attention.
all over.
You
Erica,
are
you
breaking
saying the answer?
Do I need to say the answer again?
Please.
It's -1 in the numerator. The denominator, it's x. And then x squared minus 1 under the square root.
Members, did you get that?
Yes, sir.
No,
Okay.
sir.
Yes, sir.
Ndumiso, I think you had a question.
Yes, sir. Where does in the numerator, where does that -1 pop up? Because in the numerator, I have a +1, not a negative.
Oh, I can explain. Oh, Erica will explain actually.
Okay, my negative comes from the denominator where it's actually -1. Negative x for the absolute value of x.
Okay.
It's just easier for me to move the negative to the numerator.
Ndumiso, you clarified?
I still, no, sir, I still don't understand because in one of my steps, I have a -1 multiplied by I have -1 multiplied by 1 over -x radical sign x squared minus 1. That's why I got a positive answer, not a negative. So I'm confused as to where that -1 comes from everybody else, like how they got that -1.
The derivative of negative x.
Is -1.
Yes, so I have -1. I have that derivative of -1.
Okay, cool.
Oh,
And then
Nondumiso.
And Dumiso, my brother.
Oh, so Ndumiso.
No trouble.
Like you use that one where inverse of second equals to negative derivative of x. Yeah, I think it should be positive also when I look at it, because original formula says negative derivative of u over absolute value of u square root of u squared minus 1. So -1 times negative, it's +1. But yeah, I think it's positive, but I'll double check.
Are we okay on number 8?
No, we are not.
the negative is an issue of contention.
What is the problem? Negative.
Or
Literally,
-1.
The problem is the negative, sir.
Yes,
It's
sir,
not
because from what I
absolute
hear,
value.
everybody got a -1 at the numerator, but I got a +1. So in essence, everybody's answer is negative, but my answer is positive. So it's
That's
just a
because
sign.
you studied.
Hmm?
Yeah.
Sibusiso is breaking, so I don't know what to say.
So I think it should be +1, to be honest.
Okay, Lerato, do you mind explaining why it should be +1? So maybe we can all understand, please.
The inverse of second u,
yes,
it's equal to negative derivative of u all over absolute value of u square root of u squared minus 1. So it's negative
Then what is
times the derivative of negative x, which is -1. Then negative times negative, it's positive.
Okay.
According to what I was given by Ishmael.
Can I ask something? Mr. Ishmael, what's your answer?
Shit. Oh, sorry, I'm not muted. So I got 1 over, but I kept the absolute value signs. I don't understand how you guys got rid of it. But anyway, 1 over absolute value x square root x squared minus 1. -1 over. And the reason I've got -1 is if you differentiate negative x, you get -1.
Yes, and the absolute value of negative x is?
I'm still confused about absolute value. So if you've got a negative absolute value of a variable, then do you get rid of the absolute value signs?
I stand to be corrected, but as far as I know is we generally, again, I stand to be corrected, people. As far as I know, we use the absolute value sign when we want to get the positive value of a number or a variable, I would assume. Because I know that absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 1 is 1.
Let's say it's like Ndumiso and Theo.
Oh, and can I say something? We usually use absolute value. I know this is for MAT1503 when you're calculating the magnitude, and the magnitude is always positive.
Of x.
Okay.
Yeah.
Like Ndumiso.
Yes, sir.
Before you remove the absolute value thing, you have -1 on top.
Yeah, I have -1 in the numerator, yes.
So the problem is this absolute value. In your case, it's -x. And in everyone's case, it's +x.
Yes, but
Yes.
but Angiti, if we're finding the absolute value of the thing, absolute value of -x, absolute value of -u would then be u, wouldn't it be?
We agree.
So if Sales agrees, There's nothing we can say.
No, it doesn't. No, Lerato.
Yeah, because also, can I say something? Think carefully about how Erica explained the answer. Remember how when she gave us the answer, she said it's -1 over x times square root of x minus 1. And she was very careful to say x and not absolute value of x, because x is the absolute value of x. Because the formula says give whatever value is the equivalent of the absolute value of x, of u in our formula, based on what Ishmael said yesterday. And so what would then be the absolute? So think about it this way. If in the bracket we had -2, and the formula says give the value that is the absolute value of -2, what would you write there in its place?
I didn't write it.
You'd write 2.
No.
Lerato, think about it. Lerato, think about it.
It's
Can
like,
I ask a question?
Yeah, sure.
So, okay, we all agree that when we differentiate -x, we have a -1 there.
Yes.
Okay, then we're going to multiply. So this is what I have when I multiplied. So I have -1 multiplied by 1 in the numerator, and then in the denominator, I have -x there. So I think that's where my calculations are going wonky there, because from what I hear, it sounds like in the numerator, everybody has a positive x and not a negative x.
No,
From the denominator.
The numerator, it's a -1, and the denominator is a positive x, yes.
So why is that x positive? That's what I'm...
Okay, I'm glad you asked. And again, to everybody, if I'm wrong, please correct me. So the reason why that x becomes positive is, Angiti, the formula says to find the derivative of secant, it's u prime over absolute value of u, and that's multiplied by the square root of u squared minus 1, right?
Is it absolute value of u?
Yes, it's absolute value.
Back, sorry.
And yeah, the
this-
formula is absolute value of u, and in this case, our u prime, if our u is -x, our u prime would be -1. We agree on that, right?
Yeah, because I'm looking at, like, because now I'm referencing the formulas that, or the, you know, now I transcended calculus book.
Oh, I'm not looking at that. Sorry, so I can't corroborate what you're saying. Sorry.
Then maybe my issue was with the book then, because the book for the derivative of the inverse of secant, it doesn't have an absolute.
Okay, but can I do something quickly?
Yeah.
say,
Please hold for me, né? I'm gonna try do something. So where is this thing? Looking for the chat. Oh,
I'm
there it is.
waiting, Rajo. Let Theo end me, so.
Thank you. Sorry, guys. So sorry for the delay, guys. We are so sorry.
No problem. No problem.
So I just posted what we were given yesterday, né? Check in the chat.
Yeah, okay, I see it.
Yeah, but disclaimer, you see all the value, you see all the calculations on the right. They should be negative u prime, by the way. Sorry, there are no negatives there. They should all be negative u prime. But it's fine because secant is correct. So it's u prime over the absolute value of u times the rest, right? And in our case, if what we had in the bracket was -x, the derivative of -x would then be -1.
Yeah, so like I see like this particular formula you're giving me is different from the one that we have in our calculus early transcended book, because they don't have a, what do you call it, those absolute value symbols around the
Okay.
The, yeah. Okay, no thanks.
So are we together now?
Yeah, no, we're together, thank you.
No, thank you, brother.
Hi, sorry guys, I'm back. My laptop had died on me. Can I share my answer? I don't know what was the solution to the joke out.
Who's talking?
It's Dennis.
Oh, okay, Dennis. Yes. Please go ahead.
Okay. So for
may we please all pay attention? We're still on number 8, eh?
Oh, it's still on number 8.
Yes, Dennis.
Oh, okay. My solution for number 8 is what? -1 over absolute x square root of x squared minus 1.
Agreed.
The way I got that is, okay, what is this? The derivative of secant, well, arcsecant -x, that's 1 over absolute value of x times the square root of, what is this? X squared minus 1. But then now we have a negative x in the bracket. So we have to multiply by the derivative of that negative x, which makes it negative.
Yes.
Negative 1 over absolute value of x times square root of x squared minus 1.
All right. Great explanation. Thanks, Dennis.
Say,
We haven't touched on number 9, right?
No, not yet.
say,
Yes, my brother.
there's something. I'm bringing up another fight now, and this fight they thought was handled. The absolute
Sorry?
value. They thought this fight was handled already, but I'm bringing another. The absolute value of negative x, I believe, is absolute value of x.
Yeah, absolute value of x is equals to x.
Yeah.
It's the same.
It's the same thing. Absolute value of x is equals to x.
Are they deceiving me or not?
No, it's the same thing. Also,
I
So
checked my.
absolute is there to eliminate any negatives.
yes. So even if you still put the x and absolute values in your final answer, we still know you're saying the x is definitely positive, and that's what we're looking for.
But you agree that absolute value of negative x is absolute value of x,
which is equals to x.
Which is x.
Oh
Yes.
man, now to prove
It's still the same
point.
thing.
No, Lerato, you're overthinking again.
You are telling me x and absolute value of like is the same thing.
Yes, because remember, Lerato, look at it this way, right? Conceptually, the absolute the job of the absolute value is like I said, it's 1503, something I know you're very good at. We use it to calculate magnitude, and magnitude is always positive. So we always put whatever we're working in absolute value brackets or lines, whatever they're called, so that the answer is always positive. So the absolute value, for example, the absolute value of -1 is going to be 1. And then if you put 1 in absolute value brackets, it's equals to 1. And again, please tell me, guys.
Absolute value of -2 is absolute value of 2, which is equal to 2.
Yes. Yes.
Let me hear. Yes. I want to hear another mind, like Ishmael.
Please, yes.
Guys, I'm a little bit confused here now as well, right? So I understand that if you say that absolute value of negative x is equal to x, I agree with that, because if x, for example, if we make x equal to -2, then the minus multiplied by -2 makes it positive, in which case you've always got a positive number. But if you remove the absolute value signs around the x, let's say this minus x wasn't x, and you remove the absolute, and you now, if in the formula where we say absolute value x and you just make it x, what if the variable x has a value of -2? Then you're going to end up with a -2 instead of, if you leave the absolute value there, you know you must make it positive. But if you take away the absolute value, you're now saying x, and x could be a negative number.
Ooh.
But then
I'm asking. I'm
no. I see what you mean. I see what you mean. Okay.
No, like Ismail, what they're trying to say is, I'll tell you from my experience. I have a lot of it, by the way.
Yeah.
Let me share my expertise in this niche. If you agree that the absolute value of a negative number is positive, and they ask you what is the absolute value of -1, just write 1. You don't need to know how they got to that 1. For example, if you look at me and I do MAT1512, I don't know what I is equal to, but I know when there's a number that does not exist, I put I there. It will work out in the end. Same thing. If you know it's negative turns to positive, like from today, I know negative absolute number, positive.
Guys,
no, what I see.
Can I try explain this absolute value thing differently but similarly?
Explain.
And I think this might fix it for all of us. So let's say we had a number line, right? And it went from 0 to positive infinity and 0 to negative infinity. And then I said to you, what's the absolute value of -2? What I'm basically asking you is, how many units would I have to move to get to 0 from -2? How many units? I'd have to move 2 units. And then if I said to you, what's the absolute value of +2? How many units would I have to move on the number line from 2 to get to 0? How many units? I just want the number. How many units?
2 backwards.
But what's the number?
2.
There we go. I hope that explains it.
No, Theo, but I fully understand that when you're working with a number, but when you're working with a variable, you don't know the content of the variable. So on the last step, if you remove the absolute value sign in the formula, no one knows that you're looking for the magnitude. You've just given a variable, if you understand what I'm saying.
I do. I hear you.
So then your formula would be wrong, because if for example, if you were to plug that into a program, because you've left out the absolute values around the x, you're now going to get negative instead of 2, which is what you wanted. So let's say x equals to 2. And now you work everything out, but you want the absolute value of x at the end in your formula. If you remove the absolute value bars, you're going to end up with -2. That's what I'm saying.
May we please reach a conclusion? What are we concluding on?
I love this group. I love this group.
What are we
The
concluding?
conclusion.
I'm asking the question. I'm not actually saying. Theo could be right. I'm just confused around that, because a variable, you don't know what the value of a variable is. It's not a constant.
Yes. Yes. Ismail.
Yes, sir. Sorry for adding to the confusion, but I'm also confused.
Glad you did. I'm glad you did, because you're getting us all thinking. I'm glad you added to this confusion personally. Guys, does anybody else want to comment, please? Help us, please.
Yes, I want to comment.
Thank you, Tando. Please help.
Go to daddy uzokutshela. Hamba kusise kuthelele. Ngisabhizi. Hello.
Hey, Tando.
Yeah.
Yeah, so what was your final answer for number 8?
My
Because
final answer.
Number 8, I didn't even calculate. Ne?
Okay.
I just knew the answer using that theorem that Say gave us.
Okay.
And they said if y is equal to the derivative of y is equal to sec inverse of sec x, ne? It's
Okay.
It's 1 over the absolute value of x times root of x squared minus 1. So now I saw that number 8, it's a negative x now. So I just put negative on the numerator. Then I just knew the answer. I'll check the working. But in number 8, I just saw the answer like that. With now our derivative of sec negative x, of the inverse of sec negative x, I just put negative using that theorem. So my answer is negative 1 over. Hello, sir.
Hang on. Please don't misquote me. Please ask a belief. Okay. This x is positive. Okay, Tando? Tando?
Yes, sir. That's what I said. It's positive, but now the question is negative. So what I did, I just put negative on my answer.
Yeah. All right. I hear you. For now, let me leave it with you. I agree the x is negative. Let me leave it up to you to go to find out about this negative. I knew. Okay. I'm not giving you any homework today. Today, I'm not giving you any homework. That is your homework.
So can we send our work to Ma'am Dikeledi before we come to class?
You are more than welcome, my sister, to do that.
Which work now? Which work?
This one. So that
No.
we can discuss
All right.
each and everyone's work.
All right, hang on. If that is not actually, if people are not comfortable with that, we can agree to say you take this, you spend much time on it. Then the problem is this minus. Okay, for every one of you, let me request you to go and sit down and do a little bit of research. Please go and consult a number of textbooks. Okay.
Yes, sir.
Then when we meet, this is what we'll start with. Okay, it was who? Dennis and Zbusiso. Please share
And
with us.
Ndumiso's hand is up.
Yes, sir.
Yes, Ndumiso.
So may you please go back to that formula sheet for inverse derivatives? I just want to confirm something. Yeah, you can stop here, sir. Okay, for example, the inverse of sec x. So from your screen there, I see that at the bottom we have an absolute x, but like as I was saying, in the book that we're given, that's transcended calculus early transcendence, there's no absolute value x, it's just x. So now I'm confused as to which one must I use now.
That's an
Okay.
interesting question.
What is your prescribed textbook saying?
The prescribed textbook is saying for the derivative of the inverse of secant x, it's equal to 1 over x radical sign, and then underneath the radical sign, x squared minus 2. So in the denominator for the prescribed book, there's no absolute value x there. It's just x.
It's just
and then,
x.
Yes, sir. Then I remember Spiciso said that x and absolute value x are not the same thing. So now then, which formulas do I use then?
Ndumiso,
Yeah.
like the textbook that you're using, I also use it. Like above, they show you how they derived that formula for it to get to x, right? Because there must be a yes, above there's a step exactly like the one Sir has there, and then it's written on the side, change the absolute value, what. Like check step by step when they show the deriving of the formula. You will see that statement somewhere in the middle.
Okay, that's fine. But then, as I'm saying, which formula do I use then?
Use Sir's one.
Okay.
Thank you, brother.
Okay.
Sbusiso and Dennis, please wrap up with number 9.
Oh yeah.
Hand is up, sir.
Sorry?
Ishmael's hand is up.
Yes, Ishmael.
Sorry, guys. Just
Thanks.
before we move on, I've just posted here. Sorry, I just want to make sure that. So have a look at what I posted there and see. So, are we saying that if we have minus x, then we can get rid of the absolute value bars, because then that makes sense. But if we don't have a minus in front of the x, then we can't get rid of the absolute value. Because if you look at
okay.
that, if you look
Ishmael.
at that, yeah.
Okay, sorry. No, it's fine. Please, I was just going to say, please just re-explain. Please just say again what you just said from the beginning. Sorry.
Okay. So if you look at what I posted, okay, I made a mistake there. The first x in absolute value bars equals to should be positive 2 there, where I've got equals to x. So what I'm saying is, if you have, so I'm just using that as an example where x is equal to minus 2, right? So if you've got x equals to minus 2, and you've just got x, positive x, then if you don't do absolute value, you're getting a negative 2. If you do absolute value, you're getting a positive 2. On the second one, I've now put a minus in front of the x, in which case x equals to 2, because obviously negative minus negative 2 gives you 2, and then absolute value gives you 2. In that scenario, you can get rid of the absolute value bars. Are we? Is that correct? Does that make sense?
Not quite. I'm not gonna lie.
Yeah, it doesn't really make sense. Okay, on my side, it doesn't really make sense. But I'm trying to see where you're coming from, right?
Yes, I'm going to repost
let's look at this.
Okay.
I'm just going to fix the error that I had here. So the top piece. So let's say we've got a variable x, right? So I'm posting it again. Let's say we've got a variable x, and the variable x has been set somewhere to negative 2.
Okay.
Okay. If we take, so let's say the first formula we have 1 plus x, and then we say, what's the absolute value? What's the value of 1 plus x? We're going to end up with negative 1. If we say, what's the value of 1 plus absolute value of x? We're going to end up with 3. You guys agree with that?
Yes, because we're then saying it's 1 plus 2.
That's correct. Yeah.
Yes.
Now if we have that same x is still negative 2. But now on the second one, we have 1 minus x, right? If we do 1 plus, in brackets, minus x, we're going to end up with 3.
Yes, because it's 1 minus 2.
That's correct. That's correct.
Yes.
Now, if we do 1 minus, and again, absolute value x, we're going to end up, no, then we can't do that. Then if we just say 1 plus absolute value of x, we're going to end up with 3 as well.
Yes, because but you said if we say 1 plus absolute value of x, is that what you said? Yes, because we're then saying 1 plus positive 2.
Yes. Okay. Now then, then I've got, then I understand this. Sorry about that.
Yeah.
Okay, so we're all on the same page now, I hope.
The example that he gave, perfection.
Yeah, it is.
Thank you.
Ishmael, thanks for this, man. Huh.
Yeah.
Thank you.
Looks like we're gonna close off on consensus.
What is the consensus?
We agree.
With what?
That absolute value of negative x is indeed x.
X, yes.
Yeah.
So, and we agree that what absolute value basically does is it helps us get the magnitude of a value, which is always its positive value. Yes.
No matter what happens.
People
Reynolds
easy.
almost the whole hour arguing about the absolute value of a negative variable or a number.
But we got it.
Yes.
This is interesting.
Yes. Guys, I'm so glad we did this.
Okay. May we please wrap up with number 9?
Yes.
The leaders, please take us through.
Okay.
First question, can everyone hear me?
Yes, sir.
Yes.
Yes.
Okay. I think Dennis is back, so.
Yeah, I'm here.
Mr. Dennis.
Yes, sir.
Okay. What was your answer for number 9?
Okay, for number 9, I got x over open bracket, well, everything in brackets, 1 plus x squared times the root of 4 minus x squared.
Please say that again.
Please repeat.
So I've got, what is this? X all over 1, okay, everything in brackets, right? 1 plus x squared, right?
Okay.
Times the root of 4 minus x squared. That's what I got.
I disagree, eh?
You see so.
Enlighten me.
I also disagree.
I disagree. So, Spusiso, please take the floor.
You.
Spusiso? Yes.
Thank you.
He skipped town.
I got x all over open bracket the square root of 4 minus x squared close bracket open bracket 5 minus x squared close bracket.
Correct. That's what I was.
Oh yeah, Steve. I forgot that.
I disagree, Steve.
You disagree?
I got.
Okay, hang on, Lerato. Spusiso, please repeat.
Yes, sir.
May
I'm
everybody please pay May please,
yeah.
Oh, is it? May everybody please pay attention, then Lerato will come in.
Okay, Mr. Dennis, are you following?
I'm following.
Do you understand how I reached to the answer?
Wait, just repeat that again. I think there's a step I missed.
Okay,
Yeah,
I have
I
x
separated it,
all
but yeah.
over.
I'm listening.
Okay. I have x all over bracket open bracket the square root of 4 minus x squared close bracket open bracket 5 minus x squared close bracket.
Yes. That's all right.
I follow you.
Yeah, I follow. I don't know how I mix things up, but yeah, I follow. I separated my solution, but yeah.
So we agree on the same answer, right?
Yes, I agree.
Okay. Lerato.
I'm still disagree.
Okay.
Yes, why are you disagreeing?
Let me check.
This is my
double check.
This is my answer. Half times cot inverse 4 minus x squared all to the power negative half times negative 2x all over 1 plus 4 minus x squared squared.
Lerato, can you repeat?
Okay, let's say this.
Slowly.
Number 9.
Can you post your solution info quickly?
I'm busy, man, to be posting solutions, but
yeah,
I'll do it.
Please post it. We need better visualization.
Hey, yes. I heard about COD, so
I had minus.
Hey.
I'm sharing my.
We need better visualization, eh?
Yeah, no. When he said COD, he had me, hey?
Hopefully you can see, man. It's not a big deal.
It never is, brother. It never is. Never is. Okay, I'm gonna turn my screen around.
Yeah, it happens.
Oh yeah, so this is number 9, eh? No. Okay. Oh. Okay.
I was split. I think I was split there by the half.
Yeah, you were.
Yeah, I can see the half applies for the angle only, ne?
Yeah, so basically 4 minus x squared to the half is the actual angle. The whole thing is the angle. Because I think the angle was the thing in the square root, but now you turned it to the thing to the power half. So that's actually the angle, which then means that's your u.
Oh, that means cot.
Yeah, so it's cot u, and your u is 4 minus x squared to the power half.
I treated it as square root of cot inverse 4 minus x squared.
Yeah, so now when you're looking for a u prime, you're only looking for the derivative of 4 minus x squared to the half. That's it. Because remember, the formula says u prime, not cot u prime. You're looking for u prime. So you're only looking for the derivative of what's next to the cot. That's where it played you.
I was played.
Yeah, I know, brother. But luckily you've seen. I played
right.
Lerato?
I was taken for a ride.
Yeah, no.
Now you must enjoy the ride, man. You must enjoy the ride. It's a learning curve.
I played you, brother. But it's fine because you saw your error, so we're good.
And now it's fine.
Yeah. Because once you know that
the 5 like now the answer is gonna be. Can you give me like 5 minutes to do? Not
Yeah.
5. I don't do 5 minutes. I do 2 minutes. What's
Yeah.
happening?
Take it 2 minutes. Yeah, take it 2 minutes. Do it quickly, and then we'll get your answer. Then we'll close. I think.
I'm disheartened. by
No,
this
there's
thing.
no need.
Where are my sources now? My material. Okay, so it's square root of u all over. I think absolute value of u. No, yeah, there is. Negative 4x. Oh, say
Hello?
that square root, that half from the square root. Can I multiply it to x squared?
The half from, okay, let me go back. Okay.
Like square root is like minus x squared to the power half.
Please come back with your question, Larato.
Can I say half times 2 for squared?
Half times
2 for squared.
square root is a half.
Derivative of wait.
Oh,
One more
whoa,
minute.
whoa, whoa. What do you want to do?
You'll fix me later. 1 more minute.
You will be more damaged for me to can be able to fix you.
Yo,
That doesn't happen. Okay. Okay. So, okay. So it's x, and your answer, the numerator at the top, negative x.
It's
The one
possible.
it's positive.
Mm.
I got this. I got negative x all over root 4 minus x squared times 1 plus 4 minus x squared squared.
please repeat it.
Like I got negative x all over root all over root 4 minus x squared times 1 plus in bracket 4 minus x squared squared.
Brother, you know what? Nah? Post that solution too, so we can see what you did.
This solution is
Okay, I think I see what you did. There's no need for an extra squared there. So what you should do there, just add the 1 plus 4, you'll get the 5 minus x squared. There's no need for the squared on top of that after that thing, the brackets.
Oh, the square is for only u squared. It's not for the whole bracket.
It's for which one?
Like the squared for tan and for cot, it only applies to the angle only, not the one.
Okay, Lerato. Okay. Dennis will. It's fine.
Like,
can I try?
Yeah, you may go. You may go.
Okay, thanks for the floor, Dennis. Lerato, let's do it quickly now. I'm going to assume in the beginning you took your 4 minus x squared and you converted into the situation of the power, right? Where you made it 4 minus x to the power of half, right?
Yes. Then
and we agree that becomes your u on it.
Yes, I agree. That's you.
And then the next step, we put a negative there because we know we're supposed to have a negative. That's agreed, right? So we have a negative on the outside, and then we calculate the derivative of that whole thing. And the derivative of that thing becomes half times 4 minus x squared to the negative half. We agree with that, right?
Yes.
And then you still multiply by what's inside. And the derivative of what's inside is negative 2x. We agree, right?
Yes.
Now, are you seeing the magic that's happening here is now we've got two negatives. We have a negative with a negative 2x and a negative with a negative, the one we put there initially. Do you see?
Yes.
So what I do is I'm like two negatives, I change that into a positive immediately because they cancel out either way. We agreed?
Yes. And then?
So now we're going to have positive half, and then we're going to have a bracket, and then the bracket is going to be 4 minus x squared to the power of negative half, right?
On the numerator.
This is the numerator, by the way.
Yes.
And then it's going to be times 2x, yes. And then in the denominator, it's supposed to be 1 plus u squared. So it's going to be 1 plus, and our u was 4 minus x squared. I need
squared.
Well, it was the square root of 4 minus x squared. Squared, I need.
Yes.
And in this case, you see the brackets encompass the whole square root. So basically that square is going to cancel the square root. Do you see now? And then once we've done that, our new denominator becomes 1 plus 4 minus x squared. Because our bracket encompassed the entire 4 minus x squared, that square rooted thing. All of it was in a bracket squared. So then in this case, the square canceled out the square root, which then left us with the denominator of 1 plus 4 minus x squared. And then when you simplify the denominator, we have 5 minus x squared. Does that make sense?
Yes, I understand. The negative 2, when are you cancelling it?
Don't worry, we're getting there. So now we agree that our denominator looks the way it looks. Now let's finish sorting out. So I need to remember in the numerator we'd agreed that we've got a positive half, and then we've got a 4 minus x squared to the negative half and a 2x, right?
Yes.
So we're going to take the 4 minus x squared to the negative half to the bottom, and then that becomes 4 minus x squared to the positive half, which is the same as 4 minus x squared square rooted, right?
Yes.
And then at the top, we just left with positive half multiplied by 2x. I get.
Yes.
What's 2x times a half?
1x.
There you go. Answer's done.
Yes, sir. If my answer is x all over 1 plus 4 minus x squared, square root of 4 minus x squared, it's fine, still.
Yeah, you can have 1 plus 4 minus x squared, yes. And then that multiplied by the square root of 4 minus x squared. Yeah, it's still fine.
I agree with the 5.
I'm glad, brother. Thank you.
Yeah.
Okay, thank you, brothers, for helping out a brother. Thank you, members, for helping out other members. That's what we are all here for.
Yes, sir.
Then that brings us to the end of this section that we were dealing with.
Oh, no.
So next time when we meet, we'll be talking about derivatives. Next time when we meet, we'll be talking about derivatives of exponential and logarithmic functions.
Yes.
Oh. Can we then call it a night, because people like me will be in the dark at 8.
Okay. Before we go, can I please say something to the colleagues?
Yes, please.
To everybody, guys, thank you for a great week. But to Busiso and Ishmael, especially regarding today, thank you for challenging my beliefs beyond measure and making me think. That's what we're all here to do, to really question each other so that you understand that, so that you really believe in the conviction of your beliefs. It was hard, but I really appreciate the fact that the two of you guys today, we quizzed each other till we were like, okay, I'm not sure. But that's what I needed, where it's the only way we learn, where somebody challenges what you think is right. Thank you so much, guys. That I liked.
Thank you, everybody.
Thank you.
The other last thing that I need to say is that as mathematicians, we need to have inquiring minds.
Yes.
That's how we'll be able to learn. Okay. On that note, please enjoy the rest of the evening. Good night, everybody.